Hello, welcome everyone. We have another exciting day of webinar. The Human DeFi Hack is striking back. And after the Monday session in which we started to put our hands into Sophia programming language, we'll have today a session of advanced Sophia plus deployment of projects in AEproject. And we are very privileged today because we count on the support and the invaluable help of Filip Piwowarski, or the Sophia master, who might be one of the persons in the world with the highest knowledge of smart contract programming with functional languages, and namely with Sophia. And this is important for this hackathon because when you are handling or building critical applications like it's handling people's money, you'd better count in a secure language to build your stuff. And if it's even more efficient than other languages, what else? I'm not gonna talk anymore. I will leave plenty of time for Piwo and then Omar to explain your project. So please, Philip or Piwo, turn on your camera, please, and let's get this deep dive into Sophia. Thank you very much and welcome again.
Hello, everybody. I think you can see my screen now. Yeah. So let me start. So first of all, I will be talking about advanced Sophia topics. You already had a session together with Omar in the last days where he gave you an introduction to the Sophia programming language on aeternity. And today we will deep dive in some quite advanced topics, giving you, we explore the full scope of the language that it has. So some quick things before we start. I don't think it is necessary that you understand everything that we do right now. I give it just as an overview, so you can skip back in the future if you see, oh, I need something like this. This will be helpful for me, so you already know this will work in Sophia and where you can find some resources on it. And as we are not so many people right now, we can do this quite interactive. So if there's a question regarding what we have on the screen right now, you can just raise your hand in the chat, and we can discuss it instantly if there's any questions. And afterwards, of course, if there's some specific questions or any more things that you want to see or any additional examples, we can go into those as well. I think we have plenty of time. As well, I will not be using the AE Studio contract editing tool as you already know it. I will use some more advanced editor. That's just for demonstration purposes, as it's easier for me to show there. But of course, everything is possible in all the environments. And later after the call, Omar will give an introduction about AEproject, a tool where you can automatically test your smart contracts. Okay, let's start. So first of all, every smart contract needs a virtual machine or an environment that it can run in on Eternity. We first had the implementation of the Ethereum virtual machine, and then we replaced it with a highly optimized virtual machine specifically for Sophia. And this is called Fate. Fate is special. It has functions that can be local or exported. I will show an example later for all of these things. These functions on the machine level can be payable. So it's highly optimized to be used in a blockchain, as these things are native to the virtual machine it runs, and it's just not a plain register machine as in computer science. And functions have type definitions also on virtual machine level, so no buffer overflows can happen, for example, as everything is type checked down to the most basic level. And all of the code in Fate is built of basic blocks. Each basic block has a set of instructions, but they don't have addresses. They have a name they are called by, or an ID. Each of these functions has code, and code is a list of these basic blocks, and the basic block is a list of the instructions of code. and there's a control instruction to end the basic block. And using these basic blocks, there is no way to write any code to memory. So a program cannot mutate itself, if this is important. In the virtual machine, the data size is unspecified, so there's no predefined word size, meaning for very small data types, for example, a Boolean, a very limited amount of data is needed. For very big data types, for example, you have a very big number. It can be any length without having overflow problems. Also, if a longer data type is needed, it's just used. It's all variable size. And the implementation itself can choose how to store the data in the end. The implementation on Eternity is built on Erlang, of course. Fate has local variables. They can be used inside of the basic blocks to store data in numbered storage slots. Variables are local to the function call. You know local variables from other programming languages as well. And there's also no word size or byte size addresses in memory. And the state in Fate is handled in a very efficient way. For example, maps are handled differently from the other states, so it's more efficient to write a map. The more items you add, it will not use more gas, as this is some special case. Looking at this very simple Solidity and Sophia source code, this is just the identity function. You give a number and it returns the same number to you. So the most simple smart contract we can think of. In Solidity, when we compile it and look at the bytecode, the bytecode looks like this. So there's a lot of instructions looking like a regular machine language. On Fate, it looks very different, and you can also see right from the start it's a lot smaller and more human readable, where there's functions defined, an init function and the main function. The init function is auto-generated by the compiler as it has not been part of the source code, and the main function takes an argument 0, and returns it instantly. And these are both of the basic blocks of these functions of this short smart contract. So it's way simpler, and you can also see the type here. The type is down in the machine level, the integer, and the tuple, the empty tuple for our state, as we have no state defined. What does this mean for us? Fate is a lot safer on virtual machine level as it's typed. It has very structured data and arbitrary sized integer, eliminating over and underflows that can happen on EVM, and you always need a safe math library there. Fate is also more efficient. The code with EVM is about 9.6 times larger when looking at some examples, and Fate is 3 times faster in execution as EVM. Combined, this means deploying a smart contract on Eternity with Fate, you save a lot of gas costs or transaction costs in deploying the contract, as you deploy less bytes that you have to pay for to be stored on the blockchain, and less gas is used during execution as it's faster to execute, and we can have more instructions with the same computing power in the end, and thus scale about 3 times better. While we're talking about gas, I want to take a step back and explain the concept of gas again. Maybe some people don't know it or don't exactly know it. So in blockchain, we require a fee to be paid as a mechanism of spam prevention. And each instruction in our smart contract uses some gas. So each instruction that is executed by the machine adds up some gas. And for this gas, we have to pay a gas price, and with this, the fee. And any gas that we provided with our transaction that is not used by the execution will be refunded to our account. So we can use the gas to give an execution limit. We say this should not take more than this amount of gas to execute a smart contract to be safe for ourselves, and at the same time prevent spamming to the blockchain with contracts that are very execution intensive or compute intensive. On Eternity, what's special here with contracts in general each contract also has an account on the blockchain. So you can make a spend transaction, for example, with a contract, towards contract directly. And also you can spend from the contract using chain.spend in your contract code. And looking at the account, the contract, if it's deployed to this address, CT_YD79 and so on, is the contract address, and the corresponding account is AK underscore the same address. And to this, you can spend eventually. Upon the spend when the spend is received, the contract can then use it to make executions, to spend the amount of tokens onwards using chain.spend, or send it to other contracts eventually. And but there's no fallback function in Ethereum. You maybe know that there's fallback functions. If amount is received, this is not happening on Eternity. If something like this is needed, you will have to make a contract call transaction to a specific payable function and include the amount there. As I already said, payable, so any contract or an entry point. Entry point is, as you know, from the basic or beginner Sophia course, a function that can be called from outside can be defined as payable. If the contract is not defined as payable, the account of the contract that I showed earlier will not be able to receive token, meaning a spend transaction to this account will fail if the contract is not defined payable. And if the entry point is not defined payable, a contract call transaction, including an amount, will also fail. This payable helps us if we don't want our contract to receive funds from sources that it should not receive funds from, to not have them, to prevent user error. So if somebody in the wallet or some wallet is doing incorrect things, the user will keep his amount basically, because it's not going to Nirvana eventually. When we want to use the blockchain and the smart contract language, we have two possibilities to do that. First thing we can do is we can do a transaction on the blockchain. A transaction we have to do for any write operations, because for write operations, we will have to provide a transaction fee that's measured in gas times the gas price. And only if you make a transaction, the state is written to the actual blockchain. And when we just want to read things or try out certain things, but not save the state to the blockchain, we can do a dry run, meaning we generate the same contract call, for example, but we don't put it as a transaction, but give it directly to our blockchain node to run it. And this will give us a result free and also instantly. As for the transaction, we have to wait until it's mined. And in the current state of Eternity, transactions, if you do a transaction and there's an abortion happening in your smart contract because of an error, maybe expected or unexpected, you don't get a good error message right now. But when you dry run, you get a very detailed error message for this thing. So keep in mind, if you don't understand the error message you're getting back, maybe try dry running it and you will receive a nice error message. Another thing that we have to safeguard users and also developers is compiler pragmas, where we can define which compiler version is required for this smart contract to be run. For example, if there's a very old contract that you need to run in a newer version of the compiler and it's not compatible yet, or you have a newer smart contract that's not compatible to the older compilers, the compiler will notice this if you use the pragma as shown here. As maybe already discussed, but coming back to it, any function in Sophia code can be defined as a function or as an entry point. Entry point, as the name implies, are functions that can be called from the outside of the smart contract logic, meaning if another smart contract wants to call my contract, it has to be an entry point. If I want to call it via dry running, it has to be an entry point. If I want to call it using a contract call transaction, it has to be an entry point. Functions that are meant for internal use in my smart contract cannot be called from the outside, and so we cannot have any unwanted side effects from internal logic. So we don't have to add any unnecessary checks. So we can use it as a safeguard for internal operations to restrict calling from outside being more safe, and every entry point we have to expect is being able to be called from anybody at any point in time. Some parts of the standard library have already been shown in the beginner course. I just wanted to go over a few more functional style standard library functions. For example, with lists, what we can do is we can sum a list of integers and get the sum. There's, for example, a filter function that we pass a list and function. Any item of the list that fulfills the function that returns Boolean true, as a result, gets filtered in the final outcome of the list. There's list.map, where we can define a function, an anonymous function that maps our list of type A's to list of type B's. Also, for these kinds of things, I will show some examples later. So if the notation is not clear now, maybe you will get a better hang of it later on. There's an option data type I will also show later in more detail. And for example, there's a function isSum. When you come from computer science and you already have worked with functional languages, you will maybe come back to the flip function that takes an anonymous function as an argument. It flips the first two parameters and returns a function that can then later be called with swapped input parameters, and the query function that applies one argument to a partial function and returns a function with just one argument needed. And for working with tuples and triples, there's also standard library functions to get, for example, the first element of your pair of tuples, and or to swap your triples if this is needed. What you can do, first, what you will probably do when you write your smart contract, you will define some state that should be stored in your smart contract logic. And in the basic course or beginner course, we always used the record state and then defined the record of the arguments that we wanted to store. But sometimes if your contracts are very simple, what you can do is define the state as an alternative type. So here what I do in this example is define the type of state as a map of addresses to integers. And then we have to define it as, in our init, we define it as the empty map. But also what we can do is we can define the state as integer, just as the state will just be a plain integer. And using this simplification, not adding another layer of attributes in a record, can save some gas if you're optimizing for execution costs, for example. And also make something simpler of how to write and read the state. Maybe I will make a small example for, let me increase the size here. For example, what we can do is, as we have defined here, type state. Let's do it. Type state is int. So my state can just store one integer. And when I want to initialize my contract at 0, when I say when I want to store it, I just do put x. I don't have to add any additional syntax. And when I want to get it, I can just get the state. I just do state. This is of type integer. What is returned as our state is of type integer. Let's see if it works. Let me compile it and deploy to testnet using this tool. And then we let's call the get function now. And we see the result is 0 as our init was 0. Call our set function with, let's say, 42 as argument. So this is a transaction call. And then I do a dry run and I get the result. So you see the syntax is very simple and we cannot do any mistake if the purpose of our contract will just be to store this integer. And the same can be done with any type or also custom types that we defined if this is needed in your example or your case. When working with maps, what we can also do is use intermediate map updates and default values for our mapping. So usually you will have to check, is there a value already assigned to this key of my map? If yes, maybe set a new value. If no, set the first initial value or a value to start from. And with intermediate map updates, we can look at the previous value in the same line that we assign a new value. For example, here, we want to keep track of deposits to a smart contract. And here what I do is I have my state as map of address to integers that stores for this address how much balance has it put into the smart contract. So what we do is we do state, and then we look at the key call caller. If the call caller is not existent, the default balance is 0. So every account starts from 0. We assign this existing value to the variable balance in this case, and then we assign balance plus call.value. So the value that's put with the call from the call.caller will be stored in this contract. So we just have to do one line of smart contract to keep track of deposits for our smart contract. Let's also demonstrate this quickly. I just pasted the code here, as you see. It's just one line to store this. Let's deploy it. Let's look at the state. The state is empty. Nobody has deposited anything with our smart contract yet. Let's call the deposit function. Pass an amount. So this is the smallest number of eternity tokens. Let's pass 42 ATOs in this case. Call the function. As we see here, it's also defined payable, meaning it can receive balance. If it's not payable, this contract call would fail. We see it worked. And now we can look. Oh, the account has been created in our map, and the value of default 0 because of our account was not existent before, plus the called value 42 that we passed is assigned to this key in our map. Let's call it again with 42 again. See what happens. Finished. And it's 84. So it added the previous balance to our new balance. As I said earlier, we have the option data type. So this means Sophia is null safe. Values of a type always have to be defined. There's no null or undefined, as you know from other languages maybe. Everything always have to be defined. And if you want to specify something can be undefined, you can pack it in the option data type, in which case it will either be some value, or none. It's explicitly undefined. And the value cannot be accessed without explicit unpacking. So we have to look for an option data type. Is it defined? Yes, then we can use it. Is it not defined? We have to specify how do we want to handle this in our logic always. So here what we see is we have some list of addresses in a map. We want to get the address with the index I, and then we make a map lookup. Does this index, or is this index present in our map? And map lookup returns us an option of type address. Then we can switch on this entry and see, is it some? Then we can access the address directly and return the address. As you see here, address is our return value. Is it none? Then we want to explicitly abort the contract execution. Meaning also, if this is done in a remote contract call, the previous execution will also fail with this abort, and nothing is persisted. Keep that in mind if we use abort. When we looked at the option data type, it's an algebraic data type that's predefined in the language. We can also define our own algebraic data types or variant types, as they are named in some languages, and use the same pattern matching to access it. For example, here we define the data type one or both. So either the left side is defined, the right side is defined, right argument, or both of the arguments should be defined. And this is our type. So our type is left, and then it's just a left argument, right, and then it's just a right argument of type B, or it's both A and B at the same time. And this we can define like this, and then have a function that gets parsed, get left. We just want to get left, and we can get a left if we switch on our input and it's left, then we can return our left side. If it's right, we don't have any left side, so we just say no, none. So we map it to option data type here. Or it's both, and if it's both, we have a left and a right side, so we can return the left side in our getLeft function. Let me also demonstrate this quickly. We have this contract. Let's deploy it. As you did see beforehand, this defines what we've seen just now in the slide. And we have an entry point that's calling getLeft on left. And if we call that, we'll get the one returned. And also, just as an example, we can also return any type. So we have here a both of two as integer and the string. And if this is executed, we see in JavaScript or how this is returned from the blockchain as both, and then the list of parameters. Okay, let's continue. Next thing we have in the language are namespaces. So if you want to have library functions that are a little bit outside the logic or scope of your smart contract, you can define them as a namespace. And you can define their types and functions, and they can then be used from your smart contract. For example, we have here the namespace library with a number defined, type number, which is just an integer, and the function to increment the number, meaning we add +1 to our number, and this then also returns a number, and we do x + 1, and then we have our +1 function here, where we access from our contract the namespace. This returns library.number as type, and we can do library.increment or library.inc x, and then we get whatever we passed +1. So with the algebraic data types and things we have already seen, these are very common in functional languages to work like this. What's also very common is that there's no for loops in functional languages, but instead of a for loop, you would use a recursive function, meaning a function that will call itself. In my example, I have a list of accounts, and I want to spend a specific balance to all of these accounts. So here I define the list of accounts, AEK1F8, and so on, AEK2VN, and so on. And we have a spend function where we want to spend to these accounts 100 ATOs each. Our function is then defined, getting the list of accounts and the amount. We can pattern match our list of accounts. If there's no account given, there's nothing to do. So we return the unit type. This is the empty parenthesis. If this is the first case that can happen when we look at our accounts. In the second case, there is an account, and the the double colon specifies that we take apart the argument passed. So taking apart a list, we get always the head, meaning the first element, and then the remaining list of accounts here. So we look at the first account and then the remaining list of account. When we get this account, we can do chain.spend, spend to this account the specified amount, and then recursively call our spend function that we have here, that we are inside right now, with the remaining accounts, meaning it will first look at the first account, spend to this, then pass a list of just the one account, spend to this, and then call the function again, then pass as the remaining account an empty list because there's no more remainder of accounts there. And then we go into the first case and we return the empty type. But during the execution, we spend to both of these accounts. Let me also demonstrate this really quick. Oh. Come on. So here, let's deploy it. And we see here the accounts, of course, full accounts, not as in the slide, a very small one. And we call our test function. And we pass 200 as amount. And this has executed fine. And 100 has been paid to both of these accounts. Then what we can do in a functional language, we can pass functions as arguments to another function or to a variable, for example. Again, the same example, we want to spend to both of the accounts. We define the accounts, and we have a spend function that takes an argument of type function. So here's our spend function, and the type of our function is address to unit, the empty type. So this is the function that just specifies how to do the spend logically without knowing how to spend itself. And we can pass this as account, an arrow, and then chain.spend account 100. And so we pass the logic how to do the spend to the spend function and the list of accounts. And then we call this function instead of the chain.spend here. And so the spend function that we defined does not have to know how this spend logically works. It just knows execute this function on the account. And then we can take it a step further. As we've seen earlier with the A's and B's, we can use generic types. And for a list, for example, in our standard library, there's a list for each specified. It takes a function of A to B, just any type A to B. If you pass a list of A, you get a list of B. Actually, this is the example here is not correct. This would be the map function, but it also still works. Then we switch again with the looking at the array. If it's an empty array, we return the empty array, so do nothing. If it is an array with at least one element, we look at the element, we apply the function here. So we call f with argument e, our function with the current element, and then we recursively call our functions with the remainder. And using this, we can simplify our example even more. We can include our list standard library, have the same example to spend 100 attos to each of these accounts, and then we can use list for each of the accounts, execute this spend function, and of course this will also work the same way with very little code. Let's deploy it. And let's execute it again. It's still called test, and we pass 200 amount to it, attos of amount. And it also worked. With this simple example, you see it used a little more gas as our first one, as our first one had very specific logic. There was no overhead in passing a function of using the standard library. Now we introduce a little bit of overhead, but we get way more safe code as we know what the list for each can do, and we cannot make any mistakes as a programmer, for example, with this. Another thing that we can do in Sophia Smart Contracts is we can call other contracts that are defined at some address already. So here we define a storage contract. It has a state where we map any string to any string, so it just stores key value strings. We have a set function where we can set any key to any value, and this saves to the blockchain state. And we can get any key. Let's also dive here into the example. Let's compile it, deploy it. Let's look at get. For some key, let's pass test as key to our get function, and we get undefined. We have not stored anything yet. Let's store something. Set. I have to put the amount 0, otherwise it will fail as it's not payable. And let's pass test and yay this sets our key to the value yay. It worked. And now we can check what's our key test. It's yay. Now let's just put this very simple storage smart contract. And now we can look at a remote contract call. Let's say we have our contract storage deployed somewhere, and we want to use it in another smart contract, or maybe different, multiple different smart contracts can use the same storage mechanism and can read and write there. So we define our, let's define a record state with storage of type storage contract as defined here above, using its interface. And the interface of our set endpoint was give it a string, and it gives you nothing back to store something. When we initialize, we give an instance of the storage smart contract and it just saves it. And we have a save function where we just pass a value. And as you see here, we call it state.storage.set. So we call the set function of our remote contract. And in this case, I hard-coded the key workshop contract, and we just store the value. Let's jump back to the example. Here's our old contract. And let me open a secondary window where I paste in what we just had with the predefined storage here. Let's compile it. And when we deploy it, we need to pass a storage instance. So we're going to take the smart contract address of our storage here, pass it as an argument, so it will instantiate the storage smart contract. And then when we call the save function with hello world as argument, it worked. And now when we check back here in our storage smart contract that we referenced and used with a predefined key, we can pass the key here, and you see in the original smart contract that we called remotely, the argument is given. I just see there's a question from YouTube. The question is there something like a max recursion depth error? Yes, there is. Actually, I don't think there's a max recursion depth. The only issue that you may have is running out of gas. Each of the iterations will take gas. And if you run out of it, so you used all of it that's provided or the maximum allowed amount of gas, your whole contract execution will abort. And Emmanuel asked, can you please explain in depth how the chain.spend function works? Yes, let's just make a quick example. Let's define a payable stateful entry point test, as we have always had. And there we can use chain.spend. Chain.spend internally puts balance that your account owns, or the contract account owns, to this address. Let's make another function actually. Point balance is with the contract.balance, we can check what's the balance of our contract, and we can make a payable entry point fund that just does nothing. And with this, we can spend using this editor to the contract. And then we can make a stateful entry point spend that uses chain.spend to spend the contract balance, or let's say not use the contract balance, but just use 100 tokens as we had in the previous examples to one account, and I will just hard code one account here. So we do chain.spend, which spends balance that our account that our contract owns to this account. So we want to spend 100 ethos to this account. Let's compile it. Let's see if I did everything right here. Waiting. And it worked. Let's check. What's the balance of our contract? It has 0 balance, because where should it get balance from? We have to fund it. Let's fund it. Call the fund function, pass, let's say 150 ethos as balance. And this does nothing except for putting the balance into the account. As you see, it does nothing, but we gave, it's payable, so we gave the contract some funds. Let's look again of the account of the contract. So our account now has 150 ethos to do whatever he wishes to do. And to use chain.spend, the account of the contract has to have this amount of tokens. So let's call spend. It's 0, so we spend from the contract of the account, which has currently a balance of 150. Let's use spend, and as we defined in our logic, we spend to this random account 100 of our 150. It worked. So let's check our balance again. We only have 50 left. Let's try it again. And we will see it gave us an error. And our balance is still 50. As our balance is just 50, we try to spend 100. And of course, this is not possible because we cannot have negative numbers as balance. So we cannot spend more than we have. And also, oh yeah, I think that's fine. Let's go back to the slides. As the switch statement works, that we've seen previously with our algebraic data types, sum, and we used switch in our very previous example to construct our list. We can also do a more advanced pattern matching without using switch. So we can define our function 3 times. So let's say we have our function length, where we want to get the length of a list. That's first line of our function definition is then the type. So the type of our length function is we give it a list of anything, and we want to get the length, so it's integer. When we give the length of an empty list, it's 0. And then when we give the length of a list that can be deconstructed using the double colons, we take x and xs, so the remainder of the list. We put 1 plus the length of the remainder of the list, which is recursively calling this function again, using this different style of notation for pattern matching. So we can use this instead of switch. And another thing that maybe people know from Haskell or from Python, where it's also available, is list comprehensions, where we can define a list in a functional way. Here, we want to have a list of x's plus k's. Our x is in the range of 1, 2, 3, 4, and 5. And we define our k by x times x. So we would do x plus our k, but only if our x plus our k is smaller than 20. So we can limit it there. And this can work with any data type, of course, not just lists. And this, what this will give us is a list of 2 as 1 plus of 1 times 1 plus 1 is 2, and it's smaller than 20. Then 2 times 2 is 4, plus 2 is 6. It's also smaller than 20, so it's 2 and 6 in the list. Then 3 times 3 is 9, plus 3 is 12, also smaller than 20. 4 times 4 is 16, plus 4 is 20, also smaller equals 20. So our list is 2, 6, 12, 20. And then 5 times 5 is 25, plus 5 is 30. And 30 is not smaller than 20. So our list that is returned from this list comprehension is just 2, 6, 12, 20. That's for list comprehensions. Emmanuel just asked, thanks for the explanation, but where I need clarification is the fund entry point was called. Where did the 150 ethos come from to fund the contract address? Let's go back to the example. And initially, we called the fund function. So we did a contract call transaction and we passed the amount of 150 to this function. This is 150 balance coming from the account that we call it with. So if your user executes the function, it's taken from his account. For example, if you use Superhero Wallet, it also shows this amount of AE is passed together with this contract call. And so we passed 150 again in our example here. 150 we passed. This worked, and now we can check the balance again. So it's 50 that we had last time, plus the new 150 that we given together with this function call as amount. And this amount can also be accessed using call.value in our smart contract if we want to know what was the value that was passed with this contract call. Okay, let's go back to the presentation then. Last but not least, we have a concept of generalized accounts that also uses Sophia smart contracts. In a generalized account, we can authorize transactions without having ED 25519 signatures. So there doesn't need to be a signature to make a transaction on Eternity if it's a generalized account. But the generalized account has a smart contract attached towards it that has an authorize function. And with calling of this, or with using of this account, you have to pass the arguments towards this authorize function. And in this example, we do a SECP 256K1 curve signature check. So we can check the signature of another account, of another curve in our smart contract to authorize any transaction on the Eternity blockchain that has, or for an account that has previously been attached a generalized account. And of course, here in our authorize function, we can define any Sophia smart contract. So as long as it returns true or false, we can make an authorization with anything without having to use the specified curve. And last but not least, let's talk a little bit about current limitations of Sophia. So first of all, we cannot define recursive types or recursive records. So if you think about a tree structure where you have a branch and then a branch and a branch and then some leaves as a data type, this is not possible right now in Sophia because you cannot, the tree cannot reference itself as a type. In Solidity, maybe some of you know modifier functions. These are currently not available in Sophia, but this can be worked around with custom logic. We cannot call any remote smart contracts where we don't know the interface of. We always have to know what is the interface of the thing we're calling, and we cannot deploy contracts from a contract. A contract has always be created or deployed by a user. So that's for now from my presentation. If you have any questions, please let me know and we can go through them, also make some more examples if you wish. Emmanuel asks, great, it came from the call caller. What then happens in a case where a user is required to send tokens to another user? Would the chain function take the required tokens from the call caller or from the contract balance to send to the receiver? This is up to your logic. Here in our example, we put it into 2 steps. The first step is we give the account balance, give the account of the contract some balance, and then later use it. These 2 are not combined. We can do anything with the balance, or the contract can do anything with the balance. If we want to directly forward our transaction, we can do this as well. With this, we don't leave any balance ever at the smart contract. Let's use the same function, but we make it payable spend, and we don't put 100, but we use call.value, meaning we spend all of the value that has been passed with our spend function to this other account. Let's deploy the contract again. Let's call the spend functions again. Let's use 150, call it. It has worked. In our previous example, we did see it did take balance from the account and forward it, take it with the fund function to the account of the contract, and with the spend function from the account of the contract to the receiver that we defined in our train.spend. Now, when we forward the call.value directly in the spend, no balance is ever stays with the contract. All of the balance that is passed will be used in, will be passed on to the account of the chain.spend. Another question that occurred is, please, can you explain more on algebraic data types? Yeah, let's take back the example that we had earlier, where we have our types of left or right or both. Then this is our data type is one or both. It's a type that can be used and passed as any other data type. It can be either left. On the left side, we have A's, or right. On the right, we have type of B, so generic data types. Or maybe let's do it, let's code another example. We use int or string, which is either integer or string to work with our generic data types. And we can have here int as a type and string as one of our types. And then we can define our function to try it out. What we want to do is we want to get string, and But in our getString, we pass our data type int or string. So we can have an argument int or string, and we want to return the string. So if it's a string of y, we can give y. If it's int, int of anything doesn't matter, we abort because there's no string inside this data type. We just abort. And let's test it. We call our getString with integer of 1, and we call our getString with string of hello world. Let's compile this. No, I made some mistake. Unexpected identifier int. Maybe it's down to formatting. Okay, it doesn't work right now. I don't know by heart what the issue here is, but let's go back to our generic data types with those that worked. B, A, B, and let's try this. And of course, this is then not string. No, it deploys. Maybe we cannot do specific data type, but we have to use generic ones. I don't know right now, but we can check the documentation. So let's see if we call test, the test that passes the int version, it gives an error, no string, as we defined. If we call our test1 with the string hello world, then it will give our string in the getString function. Concerning the limitations, please shed more light on creating contracts from contract. So when you want to define a new contract like this, the user or somebody using the blockchain has to create a contract, create transaction on the Aeternity network in order to put this contract logic on the chain. A smart contract cannot define a new contract with specified logic. There's no function to create a contract from the logic of another contract. Contract always have to be created by a user. Is there any other question? You're welcome. Omar asks for, can we say some general guidelines for building a smart contract? So what I would do as general guidelines is first, keep it as small as possible. Don't save any unnecessary data that you don't have to have within the logic of your smart contracts. You can always reference an external storage for data that is not part of the logic of your smart contract. Second, prefer using specific types over generic ones. If you have worked with hundreds of strings in your smart contract, you will make a mistake where you pass the string that you didn't intend to provide. If you do as we did here and wrap your types into in a data type, for example, you cannot pass the incorrect thing because you will always have to check the type. And so the compiler checks for you, did you pass somewhere the incorrect type? And we can even have like for example, we have two integers in our contract that are always used within our logic. The first is just int, and the other one is an amount that always is in etos. And then we can have a just int and an amount. I think what I did earlier was like this, and maybe we can define it as hard-coded types now. Let's try it out. And when we do a spend function, we can wrap our spend function so it only gets an amount. So we can pass our account here, ak underscore something, and then our amount of y. If it's just an int that is not supposed to be an amount, we abort with an error. And just like this, we created a safe version of using two integers in our smart contract. For example, we can use any integer that we use in some other calculation and amount separately. And only if it's an amount, we can call our spend function. If it's not an amount, the spend function will fail if we pass the wrong integer, for example. So we can make it secure by using specific types. Another thing that I would say you do is use a nice indentation. Always use spaces for indentation. In our examples, we always use two spaces. So 2 spaces here, 2 spaces here, 2 spaces here. Maybe align these things so it's very clear what happens here. We can also align these things in some cases. So it looks nice reading from top to bottom. Keep the logic minimal. Yeah. And I think that's very good generic rules. Keep the logic small, use specific types wherever possible, and format your code nicely so it's readable in a very easy way. Another question is, what do we mean by switch statement in pattern matching? Switch as a statement always looks at what is inside of this X. Here we check X is of our type int or amount. It's of this type, and we can check. We defined our type int or amount as just an integer or an amount. It can be both. We don't know yet. With switch, we look at our X. What is our X? It can be, first case, it can be amount, and then we do our logic. Second case, that our X can be is just int, and then we abort in this case. Emmanuel asks, is it possible to get the transaction hash after a function is executed from the contract? Yes, of course, this is possible. When you use the SDK or anything else, you will always get it in return. A result where also the hash of your transaction is present. I don't have an example here right now. Maybe let's look at AE Studio. I think this exposes it a little bit better. Let's use this example again. Let's deploy it. So here we see we deployed it, and we get the transaction as a return value here, th_2.yu. And this it's also returned when you call it using one of the SDKs. You get this as a return value from calling. Any recommendations on the life cycle of a contract, let's say versions? For versioning, you will always have to know your data structures and how you want to change them from a version 1 to a version 2, for example. If you keep your logic very simple and split your contracts into multiple ones, for example, as we showed earlier with the storage, you make a very simple storage contract, and then you can use it from your first version and have it as 2 separate contracts. If you at some point need to change the logic of your version 1 contract, you can use a new logic and access the same storage contract, and then the users can use both versions of the contract eventually, or an administrator can forbid that you make a logic that disables the contract, so it cannot be used anymore, the version 1, if you don't want people to use it. Some more questions from YouTube. Is it on the road map to support contract deployment by contract? Yes, we are thinking about it, as some of our internal things that we're doing would also require it. I don't know the prioritization, but we know about it. Next question from Eric. Is there some random function which returns a random value in the standard library? On blockchain, you cannot have random values. Every value has to be generated from a seed. And the only seed that you have in context of smart contracts is data that you can access beforehand. So you can only generate pseudo random numbers, and you would need to know for yourself, is a pseudo random number sufficient for your example? And then you can use anything. For example, is a hash of the block hash sufficient? Then a miner could, if he knows this transaction is executing here and this is the hash of the contract that's to be executed, choose to not publicize the block and thus game your random number generator. So for casino, for example, you have to be very careful how you, if you want to use pseudo random numbers and how to generate them. There's another question. I have a structure like map of list in my smart contract to store different kinds of data. When I add an item, it's written on the blockchain, how smart contract knows in which block or transaction it was recorded in order to find it. So internally, the node does not have to know which transaction it was put in. All of the state that's generated and stored in your smart contract is stored at the central location in the node. And you access your contract with its identifier. What we had here is we use this identifier in some cases, and this is the place where your state is stored. The raw data on the blockchain is a different format than we see here. Here we see Sophia smart contract language. On the blockchain itself, we store it in fate. So fate, the underlying virtual machine, saves the things to state. And this is the translation layer between the virtual machine and the smart contract language. And they are, of course, very compatible to each other. Emmanuel said, I am sorry I did not get how the transaction hash so as to save it in contract alongside with other values. You cannot access the transaction hash in your contract. The problem is that the hash of the transaction is only known after the fact, so you cannot access it while it executes. So this is not the field that's available to you. But usually you won't need this hash. I cannot think of a use case where it's necessary to have the contract at a transaction hash of calling the contract stored inside of your contract. All of the data is stored in the blockchain. You can always go and look in the blockchain itself, in your contract, see what all of the transaction hashes were, and then use the hash from there if you need it in some logic. And if you need to keep track of transactions internally to your contract, you can give them an ID, for example. You can give it 1, 2, 3, 4, 5 and count up this ID to reference some system of transactions, for example. Are there any other questions? If not, I think I will hand now to Omar, and he will give a introduction about a project, smart contract testing tool that we have in Eternity. Thank you, everybody.
Thank you, Philip. Thank you for the presentation. Oh, sorry, Eric. Thank you for the presentation and all the responses. I guess there will be more questions, so if you have, you can just share it on the Discord, on the Telegram, on the different places we have, even the forum. Like I always say, there is no best way to learn and to see how things work than just trying yourself and getting some errors and asking what is happening, trying to figure it out. But I can tell you guys, you can count on Philip and all the team to see what is happening. So
yes, of course. If there's any question also regarding my presentation, you can find me in the forum and just tag me there at philip.chain, and I will respond to you, hopefully.
Perfect. Thank you. Thank you very much for that. Bye. Very well. Well, now it seems like it's my turn. The idea is to have a very short session about one of the tools we have that is called AEproject. Let me try to share my screen. 1 second. I'm not sure if I can. I need admin privileges, I think. 1 second. See if it works. Perfect. Very well. So please let me know if you can see my screen now.
Yeah, I can see it.
You still can see it? What are you seeing? The presentation or the navigation of the presentation?
The navigation.
Navigation. So let's do it that way. Perfect. Very well. So as I was saying, this is going to be a short presentation, just to make you all aware that we have a complementary tool that I like it very much, and I guess there is like always in technology, there is scenarios and situations where it applies better and it makes our work easier. So when you saw Pivo working, he was working on an online editor. He like to say that it's his private editor, the contracts. We also have the studio that we were looking at a couple of days ago. But there is a point where you need to work on your own environment. So and we have the right tool for that. We have the tool where we can establish our own local nodes, that we can set up our contracts, we can set up our test cases, and that we can even have our own A Studio locally. So, and that's all that is it's made available through the AEproject. So the idea for today is just making you aware of that, telling you that there is this tool, where it is, and just do a quick work through the tool to see how it works. Where you can find it, we have it on our GitHub at aeternity, and there is a specific repository for it. So you can navigate there. You can see the code. You can work from the code, or you can just follow the install instructions that we have. Some requirements, of course. You need to have Node.js if you want to have your local A Studio working. You need to have the 10.9 version of Node.js. You will also need to have Python, and of course you need to have Docker, so you can run your own local nodes. There is some more specification and at the GitHub for the project, but mainly what you need to know is this. For making installation, you just run the command, and it should be it. You should be able to run the AEproject right from the command line directly with all the different options. What's the way to use it? And as always, if there is any question, just write it on the chat, or just raise your hand, and I will be happy to try to answer if I know the answer. So as I was saying, for the use you do with AEproject is that you start up a folder and you initialize it through the AEproject. Once you do that command, it will create the entire structure you need for testing your contract, for building your contract, and to do your own local deploys. But you can also do the deploys, let's say, to the mainnet if you like. So it's a complete tool, and you have the add-in of using the A Studio right there from your local environment. In this case, I don't have it that way. I have an older version of AEproject. As I was working on a couple of projects, and while I'm working, I don't like to update anything just in case I have my operating system. But that's my case. If you download any version, you will have that option of installing the A Studio, so you can work directly into your environment and do the deploys locally, and then when you are ready, deploy it to the testnet or to the mainnet. So first thing for me is going to be initializing the folder that will create, as I said, all the structure you need with a testing contract, a demo contract, a test suite for that contract, and the node configuration you need. Once that's done, you will see that you have all that folder structure, and you can from there you can start up your environment, meaning that you will be launching a compiler, you will be launching your node, you will be launching and creating some wallets, pre-founded wallets that you can only use, of course, on that environment. Once you have all that, you will be running the tests, and what it's going to do is just compiling the contract, deploying it to the node you have locally, and then launching the test you have against that contract. Just for those that could face this error, that happens to me sometimes, at least on the version I have, and on my environment I'm on a Mac OS. if you get that error of that cannot find a module AEproject utils, just do the package install for AEproject utils. I put this on the GitHub also, so if you face that error, just make the command and it will be fixed right away. I think I have to thanks Emanuela. I guess he was the one who found this problem some time ago. Other things you can do, there is a documentation, more complete documentation about AEproject. I guess we will be working on the future on more and best documentation also for AEproject. But mainly what you need to know is that there is a way that you can deploy locally, but also on the testnet and on the mainnet. Of course, for the mainnet case and testnet, you will need to have a wallet created that you're going to be using on that deploy with some funds. Otherwise, it's not going to work. And you can see about the history of the node and the transactions that were made against that local node that you are launching. So far, any question? I guess there is not, at least on the on the meet. Okay, perfect. So it's piece of cake, yes. Like it's easy to say it from here. But at the end, what you have, and we are going to be doing a live testing, very simple live testing on how it works. You can work with our own A Studio locally. You can also use Visual Studio Code with the Sophia language plugin if you like to. You can code it, you can deploy, and you can do all the tests you need on your contract. And this way is going to be much faster than just working online, because when you work online, and this is something that only happens in our field, in the blockchain field, is that when you work and you do test cases, if you are doing it online and you try again, you will have to do that status of information again from the beginning. So if you, I don't know, if you have some logic and you have some coding inside the data structure, every time you need to retest, you will need to fill that information again. So all that process can be much more easily done and automated through AEproject, and that way also it's easier for you to maintain your contract. I was asking to Philippe about what happens when you have to do version, because it doesn't happen that you launch only one version forever of a contract. You will have some addings through time, so you need to ensure that the change you are doing is not going to break anything. So and having a proper way to do those tests, being sure that we are retesting the same use cases, and so all that is made available through the AEproject tool. So, but enough talking. Let's see how this work. I will try. Can you, Eric? I think I can do it myself anyway. Let me try, because my AEproject environment, it's on another computer, so I will have to share to the other user here, I think, and we have to grant moderator. Yes, perfect. And now I will try to share from here. Seems like it should be working that way. Yes. Perfect. Very well. So let's try to make this very easily. Let's make a new a new folder, a test 2. And here is where it happens. Magic. So I'm initializing my folder, and in my case, it's going the error I said before is going to happen. So every time I create a folder, I have to install those utils, AEproject utils. I'm pretty sure that doesn't happen with the last version and with different environments. So don't worry about it. And I can tell guys that I'm using this for production projects, so it works. Perfect. So now I have a new structure where I have my contracts folder, my deployments, my Docker configuration, my testing cases that I will be opening from, in my case, the Visual Studio Code. Let's see where it is. Test 1, no, test 2. Perfect. So if you look at the structure, the main structure we have to care about is the contract. Here we have the crypto hamster contract as a demo with all with a basic definition, but more than enough to start, where you will be handed a state with a map and essentially a list of hamsters, hashes in our case. And
sorry, Omar, could you zoom up?
Yes. Sorry, what?
Zoom the screen.
Oh, okay. Let me see. I have full screen here. I'm not sure if I can do much better than that.
Don't worry.
Yeah, I have full screen, so I don't know if I can do it better. Maybe, yeah, it seems like a little bit. Yeah, it's not fair because I have a 24 inches screen in front of me, so I'm not sure how it looks. Well, I was saying that we are going to be sharing all this anyway, so don't worry. I was saying that we have the example contract in one folder and file. This is the basic and minimum structure that you can have on a project. You can have more contracts. You can do everything that Vivo was saying, having remote contract, everything. You can do everything. So, but this is the most basic structure. And on the other side, what I have is an example test, of course, against that example contract with some testing cases. So what comes by default is to deploy the creation of the wallets. Like I said before, are when you start your environment. My environment is I would say it's always started, so it's not like I'm stopping it many times. Even when I turn on my computer is still started. But when you start the environment, the AEproject starts a node and creates some wallets with funds. Those wallets are going to be accessible from here. So you can use, I think it's 10 different wallets. So you can do testing from, let's say you have a contract that was deployed from one owner and you want to try it. If you are accessing it from a different wallet to see if the security works, if you have some required on who is the caller, you can do all that kind of different testings like it's going to be on the real thing, right? So the first part is where you deploy your contract through a wallet that is already created for you. You have access, of course, to the public and the private key, and it has unlimited funds for any test you want to do here. And then you have the different test cases, and essentially what you are doing is you call your contract, you call all the different entry points you have with all the data that you need, and to see if you are following the right response, if you are getting the right response on your contract, and when you don't have to get a good response. So you have an excellent tool for doing from the most simple testing to your contract. As long as you are working on it, you can do your test driven development from here, like working first on all the test cases and then starting to work on the contract the way you want. The usual way I do is I work on the contract, and once I think I have a basic version, start working on the test, and then I try to see how is it working, if I'm covering all the test cases, and then I try to do some more complex testing. But let's see how this work. I have my test2 folder already initialized. Maybe something I can do is just launching the tests. Oh, nice. Well, this is something that we could be expecting. This is a new folder that I initialized, so I'm getting this error, but I will fix it right away. I have it on my guideline. Let's see. Let's hope that this works. Like always, testing live is something dangerous, guys. Very well. So let's see now how it works. Perfect. So it starts with the deploying of the contract, and then it starts to execute all the tests I made. I will make some error now to see how it will respond. Of course, imagine doing this through the online editor against the testnet. It's crazy. It's not. You will take so much time on deploying, on remake the same test once and again and again and again and again. It doesn't make any sense. So this is by far the best way to do it. Let's make, I don't know. Let's try to make some mistake. Let's try to break something here. Sometimes trying to break something is a bit harder. Let's change just a test, maybe. Create a hamster, should work if it exists. Let's try to create another hamster. Let's copy that test and create another one. This in this case, this test should not work, right? So we see how it reacts. It will recompile, it will redeploy, and recheck. We added a test that should be failing because we are going to revert. I guess it's going to try to revert something that exists, but let's see. Maybe I'm wrong. The first one already exists. The second one doesn't exist. So the test is failing as expected. So of course, in this case, if I want to do this specific test, I should be changing my test to see how it reacts with I'm adding a hamster that doesn't exist. But this should be this test. So, but the only thing I wanted to show you is what happens when I do some tests that fails, and well, the assertion is going to tell me that there is something wrong or something unexpected. Let's make this back again. And it should be the same result because I'm redoing the same test than before, so just twice. So mainly what we do and what we can do on AEproject is a combination of this, having your contract on AEproject, or more than one contract. Remember that you can do everything that you need on the same place. You can deploy more than one contract, and you can have all the features that we were talking and discussing on the previous webinars. You can do it right here, because it's like you have your own private aeternity locally. So you can do as much as you need. You can have and you can add other test files also. You can do, I don't have it on the basic structure, but you can have performance testings where you can hit a lot more. So you just need to be a little bit creative on what you do, but you have the most basic structure, so you can start working from there and ensuring that the contract you are building is good, is well tested, and you are covering all the use cases you need for solving your problem. So basically, on my side, is that. Thank you very much to all. I hope you start using it. If you face any point, any issue, just reach us, and we will see how we can work it out. But I invite you all to try to install the tool. Also try to install locally the A Studio. But once again, it's like if I need to work something quickly, I need to check something quickly against the testnet or even against the mainnet, I can use directly through the studio. Also, there is a great way to share code, to seek for some help from other team members. So you can use it on that way on the online. But at some point, if you need to have your own environment, on local environment, to be faster on working and testing all your contracts, well, I guess AEproject it's a great way. So thank you again. Let me know if there is any questions. Otherwise, we can wrap up. Which turn my camera here. I'm in two places right now, so maybe stop sharing here. I'm sharing on both places, right? There you go. Perfect. Questions? Are we good? Yes, you need to have Docker, because it creates, the nodes are made, are launched with Docker. So yes, the answer is yes, you need Docker. Another question? Somebody is using it already here between the audience? I am just a very long testing name. Who is that?
I think that's Philip.
Of course you do. Of course. But you have your own version, right? You have some tweaks. Could be, or not.
Yes, I do. There are some simplification or some additional things you can do, because AEproject wraps Mocha as testing framework, and people that are familiar with Mocha or Node.js can also use native Mocha, and then you can use integrations with, for example, I use WebStorm as IDE, and I can have the tests execute directly in WebStorm using native Mocha. There's also an AEproject boilerplate project in my GitHub.
That's right. So that's open, right? So if anybody wants to check it out.
Yes, of course. It's a little bit more advanced. So what you showed is well documented and more simple to use. The project that I have is a little bit more. You have to know what you're doing.
I wouldn't expect less than that. Cool. Any Docker version? Well, the last one could be a good response. Mocha, Emmanuel, I think you said Mocha, right, Philip?
Yes, Mocha, M-O-C-H-A.
Cool. Let's write it down just in case. And Carlos, yes, the last version. I'm not sure if there is any constraint there. There is something related to Windows, but I would say that well, I don't know what's the status with Windows. Regarding to the nodes, at least we are not supporting Windows anymore. But regarding the development environment, I think there is no issue. Maybe I don't know if you have any other info regarding that, Philip. But I think you still can use it without any issue. But having the last version is always good if it works. Otherwise, you can always go to the previous version. My motto in that sense is trying always to, if there is any version and I have some projects going on, I wait until I finish that project because I don't want to mess without my development environment. So, but that's personal, I guess. Any other concern? Any other questions? From YouTube, Eric, we have something?
No, basically all the questions were already answered before in Philip's part.
Okay, perfect. Well, in that case, as I said before, if you have any concern, you can reach us through all the different channels we have. We are here to help, and we hope that you start building awesome stuff with blockchain and aeternity technology. So just saying thank you again. We will have more actions tomorrow and after tomorrow, and I think we have on Monday, next Monday, we have a very cool webinar for specifically oracles and AX9 tokens that our friend Philip will be doing, right? I don't know if you're still there, Philip, but anyway, doesn't matter. Okay, thank you, guys.
There's one more question.
Yeah, how could that transaction throughput be tested or is unnecessary? What you mean? If you are reaching the 120 transactions per second on chain we have, well, you can benchmark that, I guess. What you try to do maybe it's like always you try to stress a little bit your use cases if it makes sense, right? So you can do more, I would say, heavy testing, like sending a lot of transactions to see how it handles it, but you are not testing the blockchain, you are just testing your contract, I guess. So you can use it, but I wouldn't say that is a performance testing that you are doing against the blockchain. It's just your contract, your logic, and that you are testing against. And when you are working locally, Carlos, it will also depend on your local environment. So it's you have to do it from a development or a use cases testing perspective more than the performance itself of all the infrastructure. So to the mainnet, well, you can have your own nodes, that will help you. But still, if you don't have it and you trust on other nodes, well, it's like, okay, I can't speed up this, but you can still have, I don't know, performance testing on your own logic, how you store things, how, if you are using maps, lists, how fast it goes. I have another question here. Is it possible to create a mobile app that can interact direct with my contract? Well, that's a good question. I would say that so far you have to go through, well, I guess your API, or against a node. So you will have to call your contract. You can do it directly from your app, I guess. Yes. But usually you have your own logic on the middle. But well, depends on the problem. My answer there will be, let's see the use case and see what could be the best solution. Sometimes you want to be fully transparent, and if you can go directly to a node, it will be better. But sometimes you have your own logic in between. So I guess it will depend more on that. Very well. Once again, thank you very much. If there is more questions, just feel free to share them on the different channels we have. I hope to see you all tomorrow, same time, same place. Thank you, guys. Bye.